Okay guys, let's jump right to it. We need to review graphing of exponential growth and decay functions and also logarithmic functions, which are really the same thing as graphing exponential growth or decay functions, but just switching x and y before graphing. Anyway, let's take a look at this one, y equals 2 to the x. That's the most basic type of exponential growth function. All you have to do is make consecutive integer inputs right here that are in order, and then you could come up with the outputs really quick. Let me put consecutive integer inputs. So we have those consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. And now let's simply plug in, start with 0, that's the easiest one. Plug in 0 right here. 2 to the 0 power is going to be 1. So when we plug in 1, you could take the 1 and plug it in here and think 2 to the 1 is 2. Or you could simply take this output, and because we have consecutive integer inputs, we could multiply by the base 2. So 1 times 2 would give us 2. And 2 times 2 gives us 4. And 4 times 2 gives us 8. So we have the coordinate 3, 8, 2, 4, 1, 2, and 0, 1. And if we were multiplying by 2 times 2 times 2 times 2 going this way, then going backwards would be multiplying by half. Times half is 2. 2 times half is 1. 1 times half is 1/2, and 1/2 times 1/2 is 1/4, and 1/4 times 1/2 is 1/8, and so on and so on. So we have all these coordinates to graph this exponential growth function. So let's start off by graphing 0, 1. Where is 0, 1 at? 0, 1 is right here. And if we go to the next one, 1, 2, 1 on the x, 2 on the y, it's right there. And if we go to the next one, 2, 4, 1, 2, 1, 2, 3, 4, it's right here. If we go to the next one, 3, 8, 1, 2, 3, 8 is all the way up here, 2 from the very top. And then if we go to -1, if we go to this guy right here, -1 and half, so you're going to go -1 and then halfway up. It's not even all the way up, it's halfway up. So it's going to be right there. And then the next one is -2 and 1/4. So that means you're going to go -2 on the x, 1/4 of the way up. And as you can see, it gets closer and closer and closer till it actually looks like it's touching the x-axis, okay? And there is no h or k shift, so this is your graph. All you have to do is connect the dots, right? And you have yourself your exponential growth function. And from left to right, it was at nothing, and it truly does grow forever. Okay, now what if this is an exponential growth function. What if your exponential growth function had a h and k shift? So what if I move this box to the side and move this over, and I took a look at this new function, which has a h of -3 and a k of -4. The only difference is that you identify that your h is -3, which means 3 to the left, and you identify that your k is -4, which means 4 down. And then after identifying h and k, you simply ignore h and k, and you graph this guy, which is y equals 2 to the x, by making the same xy table that you did over here. So you'd have all these coordinates that relate to y equals 2 to the x. And then at the very end, you're going to shift 3 to the left and 4 down. So you graph all your coordinates the way we did right here on this exponential growth graph. And then we simply translate all of our coordinates 3 to the left and 4 down. So if I were to take this guy, this first guy right here, and go 1, 2, 3 to the left, and 1, 2, 3, 4 down, I get right here. If I were to take the next coordinate, 3 to the left, 1, 2, 3, and then 4 down, 1, 2, 3, 4, I'd end up right here on the x-axis. Then take the next one, this guy right here, and go 3 to the left, 1, 2, 3, and then 1, 2, 3, 4, I'd end up right there. And that is right here. This does take a while. And the asymptote itself, guys, the asymptote itself, if I were to take this asymptote of y equals 0 and move it 4 units down, 1, 2, 3, 4, I know for a fact that it would be right here. Whoa, it's supposed to be touching, so you don't want to leave any space right there. There's my new asymptote. And of course, it looks like I forgot one more coordinate. I believe this guy. Let's go 1, 2, 3, and no, I already did that one. Let me see. Well, looking at it now, it looks like I messed up. This one right here should have been 1, 2, 3, 1, 2, 3, 4. So it should have been down here. I apologize. Let me put that one there. And let me erase that other one. Oh, sorry. We'll just put a little white out on it. Anyhow, we see that our exponential growth function, which I believe is missing another one right here. Sorry about that. Is this one. The original wasn't hit. The original was from this guy over here. So if you were just graphing this guy, yeah, it's the red one. But if you have an H and K shift, it's the same exact thing, but you just move it 3 left and 4 down. Okay, that's exponential growth. We also have exponential decay, which is done the same way. But let's actually move on to a logarithmic function. Okay, so what is a logarithmic function? Let's do one right here. So right here we have a logarithmic function. It says y equals log base 2 of x. And in order for us to graph this one, we're going to pretend that there is no, give me a second, that there is no log. So what do I mean by, let me see if I can make this smaller. There we go. We're going to pretend that there is no log. So what does that mean? That means you're going to pretend that it says y equals 2 to the x power. And you're going to make an xy table for y equals 2 to the x power. And you're going to get coordinates. Now remember, we're just covering up the log and just making it look like y equals 2 to the x. And we only did that by covering up the log temporarily. That way it looks like y equals 2 to the x. And we could come up with the coordinates by doing the consecutive integer inputs and then pulling out our outputs and getting a bunch of easy coordinates for the exponential function. But these coordinates are only going to be the coordinates to the exponential function, not to the logarithmic function that we have right here. Okay, so as a matter of fact, we already did y equals 2 to the x, and we got all of these coordinates up here. All of these coordinates are the coordinates to y equals 2 to the x. So what I'm going to do is switch all of those coordinates, and that will actually give me the coordinates of the logarithmic function. Okay, I hope you guys understand that. If I do the coordinates of y equals 2 to the x, I'll get all those coordinates that I got up there. But I don't want the coordinates of y equals 2 to the x. I want the coordinates of log base 2 of x. And here's the fact, guys. This is the inverse of this guy. And how do we find the inverse? We switch x and y. So if I know these coordinates, all I have to do is switch them, switch the x's and the y's, and I'll have the actual xy coordinates to the logarithm. So let me do this. Let me put an xy table right here, and let me actually write the switched coordinates so it'll actually give me the coordinates of the logarithmic function. So let's go up here. And the first coordinate is -3 and 1/8. So I'm going to write it down as 1/8 and -3. 1/8 and -3. Okay, let me go to the second coordinate. That's -2 and 1/4. I'm going to switch them and say 1/4, 1/4, and -2. Okay, let's go back up here and let's take the next coordinate, which is -1 and 1/2, and switch it to 1/2 and -1. 1/2 and -1. Let's go back up here, and we have 0 and 1, but let's switch it so it could become 1 and 0. And let's switch the next one from 1, 2 to become 2 and 1. 2 and 1. If you're wondering what I'm doing here, I just took the 1, 2 and switched them to 2 and 1, because 2, 1 is the actual coordinate to the logarithmic function, not to the exponential function, right? So moving on to the next one, instead of 2, 4, we're going to have a 4, 2, and instead of 3, 8, we're going to have an 8, 3. So we're going to have a 4, 2, and an 8, 3. Okay, so these guys really are the x and y values of the logarithmic function. Okay, so let's see how they fall. And if we were to graph these guys, we're going to start with the coordinate 1, 0. That's an easy one to do. If you go 1 on the x, 0 on the y, you end up right there. If you go to 2, 1, 2, 1 is right there. If you go to 4, 2, 1, 2, 3, 4, 1, 2 is right there. If you go to 8, 3, 8, 1, 2, 3 is right there. So as you could see, this is curving this way, okay? But when we get to 1/2 on the x, -1 on the y, so you're going to go halfway on the x. That means you don't even go to 1, you go halfway to 1, and then you go down to -1. So you're going to be right here, halfway. And then as you go to 1/4 and -2, that's going to be even closer to 0, but at -2. And then 1/8 is even closer to 0. So you know for a fact that it's going to infinitely approach, but never actually touch. So your graph, it's going to look like, it should look like it's touching, even though you know it never actually touches, just infinitely approaches. And if you connect these dots here, there is your logarithmic function, okay? So what if this is just a regular parent graph, this is just a regular parent graph, y equals log base 2 of x, but what if it actually had an h and k shift? Well, right here, we actually have one that has an h and k shift, right? So once again, just like always, whether it's an exponential growth or decay function, you identify your h and your k. So in this case, h is -3, which means 3 to the left, and the k value is -2, which means 2 down. So you identify h and k, and after that, you ignore h and k, okay? So we're actually just going to box in the parent graph, once again, y equals log base 2 of x, ignoring h and k. Now, if you do that, you'll be able to have log base 2 of x. And how do we graph log base 2 of x? We remember the process. You cover up log, and you do log y equals 2 to the x, and you get the coordinates for y equals 2 to the x, and then you switch the x and y values, and you get these coordinates. So you have these coordinates, which are graphed right here, and then afterwards, it's just a question of taking all these coordinates and going 3 this way and 2 this way, right? And you'd be able to get your new graph. So there's our first point, and then if we go to the next one, you go 1, 2, 3, and then 2 down, you end up here. Then you go to this next one, that's going to be 1, 2, 3, and 2 down, you end up right here. And you go to the next one, or you could just take your asymptote, which is this blue one right here, and move it 3 units this way, 1, 2, 3, so you end up right here, like this. And there's your asymptote. You already know these red dots are your coordinates, so if you just curve it into your asymptote, then you'll have your graph of this guy right here, of the whole thing. So I hope this kind of clears things up. If you're still confused, please post whatever you have questions on. Ask me questions here on Edmodo, and I'll get back to you as soon as I can.